Hi, in this episode, we'll talk about the Log4j vulnerability, which is now in the news. Everybody is talking about it. So, it's basically Log4 shell or a 0-day vulnerability, which was found in Log4j. So, it is actually getting the shell access through Log4j. Through logging, we can just get the shell access. So every application, especially Java enterprise application, they need to log information for debugging, etc. purposes. So that's what the vulnerability is. The attacker are using it. This vulnerability was found in December 24th and was patched on 6th of December. November 24th and was patched in 6th of December. So what it does is it was actually introduced somewhere in 2013, and up till then nobody was aware of it, and a lot of application was compromised due to this vulnerability. So what it does, it simply send a string to the application, and if application is trying to log that information, it will simply give the shell access. How? This is a simple code where we have exposed a simple URL and it accepts one parameter, so it's something value. You can pass anything here, and it's just simply logging that information. Here the hello and whatever the value is, it will be just logged. So this was pretty simple. This is the expectation, but what it actually does is by passing a magical string, you can get the shell access. How do we get the shell access? JNDI lookup, which is basically Java naming and directory interface, which enables the Java to load anything, any serialized object reside on a remote location. So that's the simple technique which was used, and this was the flaw or the blunder of this open source library. So let me show you that string. So here we can see here I'm passing a value which is simply a string, which is JNDI LDAP. So try to look up through an LDAP, and if LDAP has that serialized object, a code which can take over, because it will simply try to load that object in the JVM, and once that is loaded, it can do multiple things. So let's launch our attack. So by sending this URL, it's supposed to be just get printed on console, and that's it, nothing more than that. So if we come here and we look at the console, it not only print this string to console, but it also try to look up a remote URL on an LDAP address, and as this is just a fake address, that's why it's not able to look up. Otherwise it would have loaded the Java class or the serialized object, and it can do anything that is possible. So that's how this vulnerability works. That's how this attack works. But let's assume somehow even if we get the context or the serialized object, we might be able to load into the JVM, but maybe we are not able to execute it. We can access the information actually. So let me append one more string. So here I'm adding a variable which is like env environment. So just read the key from the environment variable and read the secret. So let's do this, and we'll see here another request, another lookup has happened here, and we can see here. So it is getting the key, which is JSON bourne, and touchstone is the password. So this is how we can get the information, and we can send it to our remote server. Our server may be logging it, all the requests, or even we can parameterize it to send it as a parameter. But just to show here the sample I have used in this way. Now it's trying to look up, like if it is a correct address, it will not only try to get the object, but it will also send the environment variable information as well. which I have just configured here, and almost all the Java application have environment variable where we pass them key and secrets or other information, etc. So it's really necessary that you encode them, you encrypt them, and then use in your application. Now about how to fix them, I have here shared this Java code, which is a sample Spring Boot application. You can use this to make those attacks. Here is the sample how you can attack it and how to fix it. So Spring has shared, because this was a Spring Boot application, and mostly when we are working with Java, so Spring Boot is widely used. So how to fix if you're using the parent POM file. Let me show you. I'm using here the POM, and we are using here Spring Boot starter as a parent. So if this is the way you are using Spring Boot or Java application, you just have to add this one line, and it will point to new patched library, which does not have this vulnerability. This is just newly patched version, and that's it. It will fix your problem. Otherwise, you can use, if you are not using that way, you can use the dependency management and then specify this version. If you're using Gradle, then you can specify the version. So there are different techniques which are mentioned here. The basic thing is you have to adopt the latest version which is patched for these types of vulnerabilities. So that's it. Let us fix the problem by just removing this comment and refresh. It's refreshed, and I have also restarted the application. Now our demo application is running. So let's try the attack again, and let's look at the result. Now this time there is no JND or JND lookup. It's just printing the value the way I passed it. So before that was just replacing these variable with the environment value, the exact value. So now it is fixed, so that's why it cannot do the lookup, etc. One more thing, to be 100% sure that everything is fixed at your end, you can just run the command, which is mvn dependency tree. It will print whole dependency tree of your application. And if we look at here at the log4j here, so it is pointing to the latest version. So you can just look up the application. These are basically specific version. So we are using 2.17, and all the libraries, all the dependents should be using this one. If it is not, then you can simply exclude. If some library is dependent on the older version of log4j, you can just exclude using the exclusion in the dependency, and then it will automatically take up the latest version which we have mentioned here, and in here the version number. So that's it. Thank you so much. Take care. Bye.